Hello and welcome to Mix and Jam, a channel about game development experimentation. Today's project is inspired by Superhot. Superhot is a very creative game in which the main mechanic is that time only moves when you move. That results into a gameplay that is not only fun to play but also fun to watch. I wanted to try and replicate the mechanic and visual style from the game using Unity. So here are the steps I needed to follow for this recreation. Implement the FPS controller and also the target models around the scene. Figure out how to achieve a similar slow motion effect. And add some final assets, particles, and effects. In order to get a good FPS controller, I downloaded the FPS Creator Kit project from the Learn session on Unity Hub. This kit is basically a template for an FPS game, so I adapted the character controller from it into my project. By the time I was working with this project, I imported the legacy VR samples on the asset store just to get the slow poly humanoid model, but that asset now is deprecated. But if you want to download that model specifically, it will be available on this project's repository. Then I headed over to Mixamo and downloaded a simple shooting animation for the character. One of the first things I did on the project was to create a new material for the character by making its albedo color red, and I also tweaked around the specular color so that it has a bit of yellow reflection, just like in the game. Then I created my main script for the shooting and time behavior. So I started by creating a prefab of a bullet that got instantiated when clicking. I noticed that on the game, the bullet gets instantiated in the middle of the screen, so I just decided to do the same. I created a movement script for that prefab that makes it move forward. The important thing here is to multiply the movement by time.delta time in order to work on the slow motion mechanic later on. And to replicate the visual from the game, I added a red trail renderer to the bullet prefab. Now the trick I used to replicate the slow motion mechanic from the game was to have two different timescale values depending on whether there was movement on the horizontal or vertical axis. Then the timescale itself gets lerped between those two values with an interpolation variable that would also change if there was movement from the player. Another thing present in Superhot is whenever there is some kind of action like shooting or throwing an object, time moves forward a little bit. So in order to do that, I created an IEnumerator that was called whenever the player did an action, overriding the timescale changes for a while. The other great thing in the game is the ability to throw and pick up weapons. So I added a rigid body to the gun and created a do-tune sequence that basically deattaches the weapon from the player, and it adds force and a bit of torque to the weapon's rigid body. For the weapon pickup, I cast a raycast that origins from the center of the camera and points forward. So when a weapon is a result of that raycast and the player clicks, the weapon gets attached to the player. And then I reset the position and rotation by using the doMove and doRotate functions from doTween. Then to make the enemy character react to the bullets, I add a ragdoll to it by using Unity's ragdoll window. And now that each body part has a collider and a rigid body, I add a script for each of those body parts. That script disables the character's animation when hit by a bullet. And then when going into ragdoll mode, I made it so that the script detects if the character has a weapon, and if that's the case, the weapon gets deattached from the character and gets impulsed towards our player. In the game, the enemy model shatters on specific parts, and I spent a lot of time thinking about how to do this, but then I decided just to split the character into different parts using Blender. Basically, I created a version of the model split into 5 parts, and I also exported each individual part of the body as a separate object. I also applied a new material to the faces that fill up those model cuts. So back on the body part script, When the bullet collides with a specific body part, I indicate which mesh of the original model gets deactivated and the object that's going to replace that part. By positioning the new objects in the same position and rotation as a specific body part bone, I was able to replace it in a kind of a seamless way. And when I replace the body part, I add an explosive force to the new object so it looks a little bit more like it's shattering. And then I made it so that the head object was separated into multiple meshes so that it would have a satisfying shattering effect when hit by a bullet or a gun. Then I replaced the weapons and bullets model using these assets from Sketchfab. I also created some particle effects. One was for when the bullet collides, that renders meshes instead of sprites. And I also did a particle for the gun itself, that plays an animation based on this sprite grid. Finally, I added a bunch of post-processing. The most important one being the color grading, that I tweaked a lot to make the visual more similar to the final game. I also added an emissive material on the body part holes so that it reacts to the post-processing bloom in a nice visual way. And as a final touch, I added some furniture to the scene using the gray furniture pack from Renwork Studio on the asset store. And after a bit of adjustments, this is how it turned out. The link for the project's repository is on the description below. Mix and Jam really only exists because of these amazing people helping out on Patreon.
Okay, always good stuff from Mix and Jam. And I kind of want to point out one aspect that you saw in there, and that's where he mentions he's messing with time using an I enumerator, and that probably looked like some really foreign code. And that's actually going to be what we focus on a bit today, as far as kind of general coding. That'll be kind of our little tip and trick. And then once we get past that, we'll probably start on game engines and then just kind of keep rolling with that afterward. So let me go ahead and back to my screen. Okay. All right, so let's make a new scene here. Don't save that. All right. Now, okay, so all right. Right, so where we're going to talk about, well, what I'm alluding to really is something called coroutines. And this is kind of a way to structure functions so that they can kind of pause and resume later, which can make your code look a lot nicer. And to demonstrate this example, what we're going to do is kind of make a little fake state machine of sort where you click a mouse button and you go from the idle state to the jumping state, and then the jump state takes some time and it automatically goes back to idle. So nothing fancy at all. So let's kind of get going with this. We'll go UI, and I really just want some text on the screen just to show what we're doing. And okay, so there's some text. You know what? Let's make a panel instead of just text. So if I say UI panel, let's make this dark and a little more opaque. And then I'll bring in some text. All right. So to start off with, this will be in idle state. That's fine. Look at the game view. Okay, that's telling us what's going on. All right, so now let's just make a really simple script that kind of does what I just described a second ago. So I'll come down here, create a new C# script, and state demo. I'll add this. Well, actually, let's put it on an empty object over here just to make it clear. Say this is a state logic. I'll drag the state demo on top of that. I like to put things at 0, and let's bring this up right here. Okay. So to start off with, I just want to show what state we're currently in. So let's make our states, and I'll do that using an enum. So you can say private enum states, and the first state will just be state idle. Second one will be state jumping, or jump. Jump's fine. And then let's store our current state being one of those. So states current state. Okay, and then every update, let's just make sure that we need to set that text that we actually have. So in order to set the text on the screen, we need to get a reference to it. We'll do it using the inspector. So I'll say public. I used the Text Mesh Pro GUI text. So this might not seem straightforward to you. When you first look at this and you see, oh, this thing has Pro on the end of it, you might think that this is some advanced thing that's special. And really, it's kind of a legacy naming, because Text Mesh Pro was something that was originally something on the Asset Store, and then Unity bought the company that made it and then incorporated it into themselves. So now we kind of have two different text systems. You have Unity's regular text, which can result in some pretty poor, unclear, character glyphs. And then we have Text Mesh Pro, which actually is much more likely to give you something that looks crisp and clear. So that's why we're doing that here. It's definitely nothing pro about it other than it's just better than the other one. So let's say this is current state text. Okay, and then what I want to do here is say current state text. And to set the text on this, the actual text object is just called text. And I'll set that to be equal to the current state, and then I'll convert it to a string because it's an enum. Okay. So I don't think we need start. Let's do this. Yeah, let's see how that goes. So it says idle right now, but I don't have a state called that. So if we run this right now, we should see, once Zoom gets off my screen and I click the button, there we go. So I forgot to set the reference. Let's come over here. Here's the reference right there. Let's put this right in here. And also, while I'm remembering it, let me turn on Sword Soft. I always forget. I don't want to show the spotlight. There we go. Try that. All right. Okay, so let me see. Nope. That's the spotlight. This is the drawly thing. Okay, just testing that. All right, so let's hit play. State idle. All right, so that shows us just fine, only it's cut off, so we can come over to our text box. Where is it at? Does it say image? Is something locked? My inspector's not changing. That's weird. Okay, let's add it. A fresh inspector. Never seen that before. This Inspector is acting like it's locked. All right, well, I'm going to restart Unity. Let's save this as a demo states. Let's turn it off and on again. Yeah, it's bizarre. That's the first time I've seen that, but okay. So let's see here. Panel, there's the text, and here's the text properties I was expecting to see. Text width is currently set to 200. I really want this to be more kind of stretched like that, but I would like this to be in the center of the screen. I don't know if you remember when we talked about UI before, but you can hold Shift and Control and you get like some different options inside of this menu here that are actually change the stretchy kind of behavior. So if you're wondering what that was. I really just did that to make sure it clamped to the edge of the screen. Now, what do I want to put this in the center? All right, so that's more what I wanted. Okay, if I hit play now. Okay, state idle, good. So let's move on. Let's actually implement this. So if we have two states, I kind of want to change my logic depending on which one we are, right? Kind of typical state machine stuff. I'll say void update idle. And I'll make a separate update for the jump, update jump. All right. So if we're updating if we're in the idle state, then just kind of keep things simple. I want to do a check and say if input.get mouse button down. If the left mouse button is down, then I want to consider that a jump. Be like, okay, so let's go ahead and change our state. Current state equals states.jump. Good. So that's pretty much all that does. For jumping, we want to actually simulate, the time it takes for a jump to be completed. And in order to do this, and this is kind of the first way I'm going to show to do it, we will actually keep track of the time with some private variables up here. So let's say I say private float jump time elapsed. That'll default to 0. And I also probably want to be able to specify how long the jump should take, and that's just a constant value. I'll say constant float jump duration, and I don't know, second's probably fine. And in here, if we are jumping, then we can we know we're on the clock, but first thing I'll do is I'll say, hey, if we've been jumping for longer than the jump duration, then we're done, go back to idle. So we'll say if jump time elapsed is greater than the jump duration, then I guess the first thing I want to do is just kind of reset the clock for next time. So I'll say jump time elapsed equals 0, and then I'll go ahead and set the state. So current state equals states.state idle. And if we are in the middle of a jump, right, won't change the state here. Instead, we want to say that basically that we need to keep track of time, right? That's all that this is going to do. It's going to wait for a certain amount of time and then kick out. So jump time elapsed plus equal to time.delta time. So I'll incrementally do this. And this is our really simple couple of states here, but in order to make them work, we need to actually make sure that the correct one is updating. And to do that, we'll use a switch here in the regular Unity update. Let's say switch current state. Can I automatically do this? I think I can. No. Generate switch labels. There we go. That's what I wanted. All right. So if we're in idle, call update idle. If we're in jump, call update jump. Okay. So does that all seem to look correct? Let's find out. Go back over here. state idle, click jump, and a second later back to idle. All right. So that works just fine, and this code isn't overly cumbersome because it's just kind of a really simple example, but you can imagine a complicated state machine where you have many states in here and many functions and complicated interactions between them. Can be, you know, and then there's also some bookkeeping that we do inside of one of these states that's accessible to the whole class that's up here, right? It's messier than we'd like, right? So a different way to do this would be to utilize a feature called coroutines. Okay. So in order to do this one, what we could do is we could still have these same sort of states, but this is going to enable us to not have to worry about this update function or have to have a bunch of variables up here that don't really belong to everything, right? These variables are specific to one thing. So this will result in less code and just better readability and, you know, less junk that just shouldn't be exposed like that. So that's what we're going to end up with. To get there, we're going to do, let's do this. So we'll say, we're going to use that thing he mentioned in the video called IEnumerator, which you can think of that as a way to kind of just bookmark where you're at in a function. So that's the thing we're going to return. I'll say this is a idle coroutine, that's what I'll call it. And this one will basically do the same thing. Oops, get me down here. Except when we get into this function, I kind of want this to be where execution stays put, right? I don't want to leave idle coroutine and go back to update. I want this class to be, hey, I start updating an idle coroutine and I stay inside of this place until it's time to go. And so we do this by putting a nice infinite loop right here. And well, I guess the thing is it looks like an infinite loop, but it really isn't going to be here in a second, because what I'm going to do is basically kind of do, you know, the first time I come in here, I'm going to enter this loop, I'm going to check the button press, and then what I want to do is like, hey, I'm done for the current frame, so I want to hand control back to Unity. So I'll say return, yield return, and in this case, null. I don't really care about returning anything. I just want to say that, hey, this yield keyword is kind of a special case keyword that works in conjunction with this IEnumerator to let you know, hey, I'm pausing this function and I want to resume it later. So it comes in here. I say yield return null because I'm not doing anything special. Return null just means, hey, on the next frame, let's resume this. So once a frame is passed, what Unity will do, just like Unity calls into your update function, now Unity will restore whatever the current values you had local in this function were before. Those will be restored, and then execution will resume. So it'll be up here. It'll come back up here. This loop doesn't terminate, and then we'll do the same thing again, right? And so you can see that every frame, this is going to be constantly checking this until the condition does hold. But in this case, it's not actually breaking out of this. Instead, what we'd like to do is give it a way to actually leave. So I could say has jump, or has initiated jump. It's false, and I can just say that, well, he hasn't initiated a jump. Now let's do that. And so in here, I don't really need to be, sorry, this might be a little bit out of order for you guys, but we don't really need to have this inside of our loop, right? We can pretty much just say whatever the current state is once, since we're never leaving. And and keep it at that, right? Be like, hey, I came into this idle coroutine, and I know that while I'm in the coroutine, well, that's the current state. So I can pretty much just set it right there, and then I can loop in here checking for a button pressed. And at this point, I could say has initiated jump equals true. And if that's the case, then the next time this gets in here, right, this will be false, and it'll end. And I'll know he's initiated a jump, which could allow me to jump from one function to the next. So to do that, let's back this up. I'm going to get rid of this completely, and let's do void start. I want a function just to kind of kick this thing off. The way that we execute a coroutine function is actually using a special function in Unity called start coroutine, and I can simply pass this either the name of the function, which we can go ahead and do it that way, idle coroutine, and that's going to let Unity know, okay, I'm going to start running this function that keeps track of itself. All right, so we'll come in here, jump will be false, the current state will be set, and this thing will check every single frame to see if you pushed a button. So that's good, but we need to make sure that we are able to go from idle to jumping, right? So let's go ahead and make that function. If we say, again, IEnumerator jump coroutine, this one really just needs to wait a certain amount of time. And like before, we can go ahead and set the current state equal to be states.jump. And then we can go ahead and borrow all of this logic that we have right here. But now what's really nice is this jump time elapsed and jump duration. I actually don't have to have it up here. I can go ahead and grab this, and let's comment out these guys. I can, oops, too much. Okay. So jump time elapse, I need to actually put a value in here. That needs to be initialized now. And okay, so that'll come up here, but the way I currently have it set up, Unity is going to be mad because I'm not actually yield returning anything yet, right? This would just, execution would come in here and then leave, and then that's it. Nothing else would happen. We need to make sure that we're playing nice with Unity. So let's come in here and do something similar. And maybe I'll make, let's set it up the way we did before to start off with. Say while true. And out here, I will yield return null, so that every single frame, right, it'll check the time and then add it up if we're not done yet, and then keep going every frame until we do get there. In which case, this actually changes a state, which we don't really want to do it this way. So we could say bool has completed jump. That's false. And we want to keep doing this until you do complete the jump. So let's change this to has completed jump, or until we haven't completed the jump. Keep doing this stuff. So now I can just say has completed jump equals true. You know what? I don't really have to reset the clock here. This is another advantage, right? That's more kind of bookkeeping that's really not necessary. And also, I think these are kind of in the wrong place. If every single time through the loop it keeps changing these numbers, right, that's going to be a problem. I really just wanted to do this once. So at this point, you can see, okay, I came into a new state. Go ahead and mark it. I'm keeping track of whether I completed it. Here's the properties, and now we keep going every frame until this thing is done. So while it's not complete, or if it is complete, set has completed to true, in which case it'll terminate this. And if we do break out of this while loop, right, we want to make sure we go back to the idle coroutine state. So we need to say start coroutine, idle coroutine. And I see that I forgot to do this or finish doing this on the last one, right? So if we, during the idle coroutine, if we finally broke out of the loop, I want to make sure that it now goes to you know, the correct thing. So it's supposed to go to jump coroutine. And you know, let's just go ahead and get rid of all this stuff. We can kind of compare a little bit. So with coroutines, what we end up with, you know, there's a lot less kind of bookkeeping and busy work up here. There's not a whole bunch of stuff in functions. Anything that is specific to a current state, right, is kind of all neatly self-contained. And if we're lucky, I didn't make any mistakes while kind of demoing that. Let's find out. So we got idle, click, nothing. So it doesn't seem like it even got in there to begin with. Let's see. Idle coroutine. Start coroutine. Why is this? Idle. Well, you know what? I don't normally use the string version of this, but let's just follow it and see kind of what's going on here. I'll say idle coroutine. Go ahead and call it directly. So that means that it'll execute immediately once and then return you know, this I enumerator back into the start coroutine function. But let's set a breakpoint and just follow this along. So I'm using JetBrains Writer right now, which is a pretty nice IDE. Like Visual Studio Code and regular Visual Studio are also pretty good. But let's go ahead and turn debugging on. Let's come in here and hit play. All right, so it hit the breakpoint. Now what I want to do is step into this. Not start coroutine. So I'm going to back out of that and then step back into it again. That's weird. I wonder if it has problems with coroutines. All right, well, let's do it like this. I'm going to just keep going. I set a breakpoint down here. It's not being smart about stepping into that. So let's try this again. Okay, so at least I got the execution to stop right here. So you can see, come in here, there's the state, it's initiated. Mouse button is not down. Yield return null. And execution is paused right here, but there's not really anywhere else for it to go, right? You can see that that'll be it for the frame. So if I continue, that's, oh, right, okay. So I set the breakpoint right here on this line, right? So the first time we entered this function, came here, and then we yielded right here. So on the next frame when we return, right, it would pretty much restart the while loop. So even though I have a breakpoint right here, we'll never make it back up there. We're actually stuck inside of here. So if I set a breakpoint right in here, let's do it right there, you can see, bam, there we are. So I can step over. I don't want to go into deep Unity code. Let's just start running again, and you can see here I am. Every frame is just boom, boom, boom. It's, you know, it's kind of just bookmarking our place, and this kind of allows us to read our code like a recipe. You know, instead of having to like, okay, I jump into this update function, then I come down here, and then I reference some variables up top. These coroutines pretty much read like from top to bottom. You can just say, okay, here's the logic of my state. It starts here, here's all the initiation. I follow the recipe down here, and then I'm finally done, right? It's definitely a nice thing to take advantage of. So let's see. I was kind of surprised that the string version of that wasn't working though. I'm guessing that when I click the button, will jump coroutine work? I don't know. Let's see. Nope. Wonder if it's a naming issue. For now, I'll just go ahead and change these the names in here. So jump coroutine. Idle coroutine. Let's try that. Or maybe it was working. Was I actually forgetting to set things? I guess, right, okay. So can't really expect that text to change if we didn't write the code to make it change, right? Before we had something that was manipulating this UI element, and now I'm actually just keeping track of state and current state, which I don't think I really even have to be done. It doesn't even have to be done at this point, right? It's like, I don't need this. That was used before for the update function. So let's get rid of this, get rid of that. And then now all we need to do is take the current state there to make sure it gets set. Come on. Current state text dot text equals jumping. All right. And then say idle. And I guess at this point, do we even need these? We don't, right? So it simplifies it even further. Idle, jumping, idle, nice. So I often use coroutines when I have situations like this, where something is kind of state-based. It's a small state machine, and this is one way you could go about creating your own little finite state machine for your behaviors, right? It's kind of a nice way to organize things. Or you could have like different menus. Maybe you have the main menu and there's some transition to the other menu, and now all the logic that dictates what happens when you're on a specific menu just happens in one of these coroutine states. And there's lots more you can do to make this a little more sophisticated. Do you guys have any questions about those before we switch topics here? All good? All right. So let's see here. All right. Let's just do a slideshow, I guess. Or no, I'll do it from there. All right. So I think you may find it useful, especially in your careers, not necessarily as a developer, but as someone who maybe manages or oversees modeling and simulation projects, and needs to make big decisions for how to hire, how to spend money, like what's relevant, what matters, and whatnot. The things that inform those decisions, I think, can be really, what's the word I'm looking for? But it can really benefit just from this kind of take, looking at the past, present, and future of game engines, like what the technology, like where it's been, what are like the prevalent features at each step along its evolution, and where are things going, and what are the things to consider. So probably over the next I don't know, few class periods, I'll try to do a little bit of Unity and then a little bit of this to kind of walk through and get a feel for all these different things. So start with a little bit of prehistory, right? And the time before game engines, the landscape looked a little bit like this. We did have consoles, right? Consoles kind of started their life more or less in the 70s. There was a Magnavox console, which I've never seen. It was that time. And then I actually got an Atari when I was 3 or 4, and that was a pretty good system. And all the way through these different stages, right? There's Commodore 64, there's a couple Nintendos, Sega Genesis. These were all extremely big. And the important thing to note about these pieces of hardware is that they're fixed, right? It's not like a PC where there's billions of different potential configurations of what people can possibly have inside of their rig. These are like a well-known entity. So when developers go to create something for any one of these, they have some choices to make and some different ways to think about it. Probably the optimal way to be able to do any kind of development would be if you had a fixed known platform and you had a long time to like really work out the kinks of this. If you were to look at consoles like the PlayStation 4 right now or the PlayStation 3 before, what you'll inevitably see is that at the beginning of the lifetime, games may not look or feel dramatically different from the previous generation yet. I mean, it might be noticeable still, but it takes a bit of time for the developers to really get in there and customize their software to really squeeze out every last bit of juice from the machine. And toward the end of the a console's life cycle, you end up seeing kind of these, this kind of these zenith projects, something that's like just a very optimal kind of masterpiece of what can be done with the hardware. I don't know if we saw that much with the Atari, right? Things were pretty limited. Commodore was definitely getting more general purpose, but when you start getting in a later generation, the developers really become more sophisticated as they get to know their hardware, and they build up their arsenal of code and tricks and everything else as they go through time. So from the consumer side of things, right, you had these to work with. And meanwhile, at the same time, we had this arcade hardware, right? So these were completely separate boards. And when you have this special purpose types of architectures, you can start to do things that you wouldn't normally do on something that's more general purpose, like maybe a Commodore. And as this hardware was being developed to do things that just couldn't normally be done at that time, they would gradually find their way kind of moving over into these other guys. But in any case, really, all the code that was being written at this time was done in assembly code, and assembly code is specific to the underlying hardware, right? It's like assembly is one step away from just zeros and ones, right? It's just a shorthand for doing zeros and ones on a machine. So that was all very machine specific. When you wrote your code, you often did it like that, and and it wasn't really something that you could make general across platforms. You had a very limited amount of space, and you're trying to fit all this tiny code to do very specific things. So the idea of a game engine was definitely not something you'd see for the Atari, and I would say would start to become a little bit more applicable once you start to get in the Nintendo range, but there still wouldn't be anything in these eras that really resembles anything we look at as a game engine today. So speaking of that assembly code, right, here's the whole game of adventure on this right side right here. You can see that here's really tiny assembly, and all these lines are the different branches in the code. I don't know if, we're used to calling functions and having this nice flow to everything, but right, there's no functions here, right? There's just little lines of code that say, hey, if you're here, go over to there, or if something is less than something else, jump over here, right? This is like extreme spaghetti code. And they had to do some really complicated, clever things to make all of this fit in the tiny amount of space they had, right? You can see that half of this game is code, and then the rest of this is actually the art for the game. So, I mean, it's hard to imagine, like, at this point, code taking even like a tiny fraction of space compared to the art assets. But back then, right, like the amount of code you wrote was actually eating into your budget to have art. But as we move into the 90s, this starts to change a little bit. We had the arcades, right, that had their special purpose hardware for rendering and drawing stuff, which moved over to some consoles, but those consoles still were not in any way capable of 3D. But during that era, like prior to the 90s, you had you had PCs that were really not considered gaming machines at all. You know, it was kind of like there were some games out there, but it generally wasn't something that they really compared to a Nintendo. Nintendo could have smooth scrolling, backgrounds, and parallax effects, and PCs, you know, had trouble with a lot of this. But the breakout moment was when John Carmack, whom I've referenced many times, was able to actually find clever ways of getting working within the bounds of PC parts to accomplish a lot of the same things that Nintendo was doing. So he kind of got to start doing that, and it didn't take too long to where he started doing a little bit more advanced things, trying to bridge over to 3D. So the first notable example was this game called Wolfenstein 3D, which I think I have a video of this right here. And this game essentially is using techniques that were not terribly different from what you did with the ray tracer, right? There's no ray tracing here, but there is ray casting and a bunch of planes, which is essentially what it did on a really low resolution and in a really optimized fashion. But this was kind of an amazing thing. Like, I can remember seeing this for the first time and being completely blown away. Before we had anything that had the appearance of 3D, it wasn't something that moved. It was like if you had some kind of dungeon crawling game, it'd be like, okay, now I'm here and I push up and now I see the thing that's up there. There wasn't this nice smooth continuum as I'm walking. So this kind of opened the doors for some 3D like things to happen on PC. From there, you know, he took that concept from Wolfenstein 3D, and he made the thing that probably is the first time the term game engine was actually coined. It was in Doom. And after this initial spike of interest in Wolfenstein 3D, Doom was just highly anticipated. It got a lot of press, and you know, the two main developers, like John Carmack and John Romero, the Johns, they were both car enthusiasts, and after they started basically printing money with their first game, you know, they were pretty well known for, you know, going out and buying Lamborghinis and Ferraris and all kinds of stuff. And at this point, John Carmack really was seeing, you know, he had a lot of pain points. You know, he wanted to move across different computers or port his code a lot more, and he's having a harder and harder time. So eventually, he did a really smart thing, right? He started separating anything that was really specific about a game from something that was more generalizable. And so he termed this thing the Doom engine, right? It was also as part of the promotion material, and it's kind of pretty much the first time that term entered like the public consciousness. And once Doom was there, you know, other people could actually start using that engine, right? It was something they could license. It's something other people could use, and it's something that could make other games besides the thing that was laid on top. But really, this opened up the floodgates for all first-person shooters pretty much after that. Well, this and the thing that followed, right? Doom was kind of like Wolfenstein, but it had some extra features where you had some verticality. The thing that would come afterward was Quake, and that's where we first see what we would typically, you know, looks more like what we associate with the modern first-person shooter. And see what that looks like right here. Oops. All right, so you get the idea. It looks a little bit crude, but it's easily recognizable as what we see today as a first-person shooter. And this was, when did this come out? Like 94? I don't know. It was pretty early, and it would be hugely influential on things that came after it. So that's kind of the start of the 90s, and that's where it pretty much birthed the engine. The other thing I would mention is that around this time, Unreal started coming on the scene. So yeah, Unreal's over 20 years old, right? The first Unreal's probably first Unreal Engine 96-ish, I think. And then shortly after that, you have the Half-Life game, which was based on Quake, right? This is probably the most famous example of game engines licensing another one. So a lot of game engines can actually trace their heritage back down to Quake, or well, less so Unreal. Unreal has its own mainline going forward, whereas many games actually licensed and then evolved Quake into their own engines, like Half-Life. And we haven't really gotten into the generations yet. We'll pick that up tomorrow, but let me close by just talking about the other thing that kind of defines. There are many things that actually define these different generations, right? It's the fixed console hardware. It gives you developers a fixed spec to go to, and if that's the common ground, right, then they figure out all the tips and different tricks to work around that thing. Outside of the consoles on the PC side, right, you have the graphics card hardware and the APIs that support them. OpenGL came from this proprietary IrisGL, became Open, then there's WebGL, and then now Vulkan. And there are actually many APIs that actually didn't make it, but we have DirectX, here's Metal, and there are many graphics card makers that also didn't make it, and we're left with ATI and AMD. So we will actually start digging into what features are associated with each generation, as I've decided to split them up tomorrow. You guys have any questions? Well, stick around if you want to talk.
Okay, that's nice.
One question. For the final project, what's the due date on that?
What's green?
The due date for the final project, is it not posted on the website on Sky?
I'll go back and check. I didn't see it, I don't think.
Where's assignments? Let me look. No, I guess it's just the prospectus. All right, so I will put up an assignment, an assignment entry for you to be able to turn that in and see when the date is. So I'll check that out. I'll also try to clarify citing. I remember you asked that before as well. I forgot about it.
Also, too, I was looking in the syllabus. Is there any grading rubrics that you're looking for within this game, as different topics that we've covered that you're specifically looking for, or any grade breakout?
Yeah, I started writing the final project up in a very detailed rubric, but it became so overly detailed that I didn't really want you guys to go around trying to check the boxes, right? I wanted you to have more leeway and creativity to kind of just, go wherever tickles your fancy. That said, right, like when I first gave that first lecture talking about it, I showed those projects that I counted as A's, and I think I cited a couple that were B's. That's the best I think I can do is give you those examples to showcase what level or what quality of work would get you that kind of grade. So like something with a decent scenario and good mechanics and some thoughtful artistic touches will pretty much get you an A. Like I saw one had really good gunplay, but the scenario was light. You know, that one went down to like, I think it was a B plus. But the A is kind of pretty much it hit most things. And if I don't know, I guess if it's obvious that a good amount of effort and polish and love was put into the project, that's gonna lean up there toward a better grade.
Sounds good. Yeah, I'm sitting here like not as a game designer trying to like develop some kind of game scenario that's interactive, while also bringing in all the different tool sets and different topics that we've worked on.
Yeah, the game doesn't have to be good at all for an A. No, it could be this could be a completely terrible game, but if it's well put together and I don't know, well laid out and functioning in a nice way, then that'll count.
Okay, sounds good. Yeah, makes sense.
Yeah. All right. Stop.